Hi everybody, I'm Riddhi, a lab assistant here at Hanlon Financial Systems Center, and I would like to thank you all for joining our podcast today for video interviews. We have with us Professor Zachary Feinstein, who is an assistant professor here at Stevens School of Business, and he's also the director of FinTech Certificate Program here at Stevens. He has completed his PhD from Princeton University in Operations Research and Financial Engineering. So, his research area includes a wide variety of topics such as financial contagion and systemic risks, decentralized finances and automated market makers, machine learning, financial technology, game theory, as well as fixed point analysis and set valued analysis. However, today we will be focusing on his project of automated market makers, which he is doing for the Craft Center. So, well, to start off this podcast, let us understand some basic terminologies for our viewers. So, my first question would be, what is a decentralized exchange and how is it different from traditional exchange?
Yeah, so let's start with kind of the idea of what a traditional exchange is.
Yes.
So when you think of a traditional exchange, that's really thinking about Wall Street or CME, where you have some centralized entity that people can meet and exchange stocks, bonds, derivatives, what have you. A decentralized exchange is something that's really coming from the crypto world. It's this idea that you can exchange goods directly on the blockchain itself through smart contracts.
All right, great. All right, so the next question would be, what is a market maker?
Yes, so when you are making these exchanges, when you are making a trade on an exchange, really the idea is either you find someone to take the other side, or if it's hard to do that, which happens in a lot of markets, you have what are called market makers. These are people or companies who act so that they will take the opposite side of any trade, whether it's buying from someone trying to sell or selling to someone trying to buy, and they make their profit by charging a small fee for performing this service.
Oh, all right. So now what would be an automated market maker?
So an automated market maker, again coming from this decentralized exchange idea, is a piece of code that will automatically perform this task. So without any human intervention, it will make the market on either side. So someone who wants to buy can buy assets from the automated market maker, and anyone that wants to sell can sell to the automated market maker, doing this through simple mathematical balancing equations.
All right. Okay, so now could you give us a little overview of what your automated market maker project is?
So really the idea of automated market makers, they started just a few years ago, really 2017, 2018 were the first ones in existence. And they took a very simple structure. They said, we're going to have a pool of assets, and people can trade and they can buy and sell so that this pool of assets, the product of how much is in everything, stays constant. So very simple structure, very easy to implement and to use. The problem is it doesn't necessarily guarantee the market maker is making a profit.
Okay.
So what we're trying to look into is how can we explore different structures so that we can see what are different profits and losses, what are the risks of doing this, and even trying to expand beyond kind of these simplest mathematical constructions.
All right. So, what is the current structure of popular AMMs?
Yes, so I already mentioned the most popular is this constant product market maker. So you have assets and the product of all of them stays constant. Most AMMs, most automated market makers that currently exist really take a position between kind of this constant product and what would be a constant sum. So you sum up the amount of assets in each. So there are different weights between this. The idea being the constant sum gives you a constant price. No matter how much is transacted, the price stays flat. The constant product has very high price impacts. So sometimes if you're trading, for instance, Ethereum or Bitcoin where there's a lot of volatility, having these kind of high price impacts make sense. It allows you to stay with the actual price. But if we're thinking about stable coins, where we think they should stay relatively stable
Yes.
price, you want to have a formula that has more trades happening near that price.
Yes.
So you have kind of these combinations of this flat price and this high price impacts to control the level of price impacts that you
Yes.
would experience.
Okay. So now following that up, why would we need a different AMM?
Yes, so the problem of a lot of these AMMs is they're really constructed in one of two ways. You either say you have pairs of assets, so you have dollars versus Ethereum, uh, and then you have a different pool that's dollars versus Bitcoin, or you have what are called multi-asset pools, where you
Okay.
say you have a pool of dollars, Bitcoin, and Ethereum.
All right.
The problem with the first is if you have even just tens of possible assets, the number of possible combinations grows quite rapidly,
Yes.
which means that any one of these pools will have a lesser amount of liquidity than it really should support.
Yes.
Um, if we move to the multi-asset pool, when someone is actually one very neat feature of these AMMs is any individual can pool their liquidity, can add their own liquidity to the
Yes.
AMM and capture a fraction of the profits of this market maker.
All right.
So in the multi-asset pool, I need to add all these assets, which means I'm now exposed to a potentially large number of assets, which I may not want the exposure to.
All right. Okay. Then following that up, what are the unintended consequences from these AMMs?
Yes, so there's something that is being referred to as impermanent loss or divergence loss, which is the idea that because the AMM only adjusts its price when someone trades with it, it's always trading at kind of the old price, which means it's always taking the wrong side of the trade.
Yes.
So while it's capturing these small fees from each trade, if there's a large price swing, it will be losing money.
Yeah.
So the idea, these kind of unintended consequences is as the market maker where it's able to set the price, it's still somehow losing money.
Money. Yes. Okay. Uh, well, what are the real markets that could these AMMs be applicable for, and what are the structure that might be most useful?
Yes, so one market that we've started to explore in traditional markets where this could be useful is currency markets. The
All right.
idea being that instead of looking at trading cryptocurrencies, which there are these wild swings in
Yes.
prices, if we look at just traditional currency markets between dollars, euros, pounds, yen, where price swings are relatively small, we could start to see benefits to this AMM structure. Essentially, if you go to your local bank and try to convert currencies, there's usually very high fees.
Yeah.
This would be a way to have much lower fees
Yes.
than kind of the traditional approach
Approach.
for individuals.
Yes. Okay. Can we extend these constructions to be applicable for any other kind of markets?
Yes, so one thing that we're exploring is the possibility of constructing AMMs for instance, derivatives markets. So for
Yeah.
options or futures, which even in the cryptocurrency space is a very novel idea.
Yes.
There are some preliminary companies that are working in that
Yes.
direction, but even just for general options, this is really a open question whether
Yeah.
this can be done and whether it can be done in a profitable way.
Yes, of course. Well, now finally, what is the goal for this project?
Yeah, so really the idea of this project is to push the boundaries of what we can do with automated market makers. This is both within the crypto world and in traditional finance. To really
Yes.
see, is this an idea that came from cryptocurrencies,
Yes.
that came from fintech, and can it help revolutionize not just that space, but traditional finance as well?
All right, great. Well, thank you so much, Professor Zachary, for joining us today, as well as our viewers. We really appreciate you taking time out and helping us with this podcast.
Absolutely.
Well,
Thank you.
thank you so much.